in math class, you have a lot of different terminology that you have to keep track of. That way you know what the teacher is saying or your classmates are saying. It's a way of communicating with one another. We should all know what a number is. It's just a specific quantity or amount. Different numbers could be 3, it could be 5, it could be a negative, it could be a fraction, 1/2 is a number, it could be a decimal, 3.2 is also a number. What's new when you start algebra, you begin talking about variables. A variable is a letter, and it represents a quantity that can change, which is what it means to vary. Another way to remember this is, or another way that it's used, is that if you don't know a value, if it's unknown, then you use a letter to represent it. So it could be X, it could be Y, it could be Z. Those are common variables that you use in class. Now a coefficient is when you have a number and it's placed before a variable. So let's put a number in front of a variable. And it could be any number in front of any variable. It could be a fraction as well. All right. And one thing to notice, to take note of, that coefficient, it is being multiplied with the variable. So this is a 3 times x. This is a negative 2 times y. And this is a z times 1/2. The number in front is the coefficient for each of these, and it's being multiplied with the variable. Now, a constant is more specific when you have a number that does not change, and that's when it does not have a variable. So 3 would be considered constant because it's always going to be 3. Negative 2 is a constant because it's always going to be negative 2. Now, it's often without a variable because you could have, say it's 2 times x to the 0 power. This is a little tricky because x to the 0 power is actually equal to 1. Anytime you raise something to the 0 power, you get 1. So this is the same as 2 times 1, which is 2. Thus, it's still constant. Not something you have to worry about too much, but just remember, a constant is most often just a number without a variable because it does not change. Last example, or last term on this page, is exponent. I just used an exponent up here. I gave this x an exponent. Okay? The exponent is a small number placed above and to the right. So if I have 3 with an exponent of 2, what that means is repeated multiplication. So 3 is multiplied by itself 2 times. Say I have the number 4 to the 3rd power. That means 4 is being multiplied by itself 3 times. You could also have x to the 2nd power, and that means it's x times itself 2 times. Or say it's a y to the 4th power. That's a y times itself 4 different times. You'll most often see exponents on top of variables. If an exponent is on a number, we simplify it and multiply what that is. 3 times 3 is 9. Over here, 4 times 4 times 4 is 64. You would first multiply 4 times 4 to get 16, and then multiply 16 by that other 4. That's how you end up with 64. All right, so let's take a look at these expressions here. Over here, I have a 3x, and the coefficient is a 3. That's the number in front of the variable. Now, if I multiply, say 3 times 5, that's the same as 5 plus 5 plus 5, right? So if I have 3 times x, that's the same as adding x 3 times. Now, if there isn't a coefficient, there's nothing in front of the variable. Looking at this one, we have x to the 4th power. Its coefficient is 1. 1 times x to the 4th is the same as just x to the 4th. You don't have to write coefficients of 1. This is an exponent of a 4 in this example. So x to the fourth power is the same as x times x times x times x. There's 4 of them. Now, one thing would be good to take note is that this example above, its exponent is 1. That's because it's 3 times x, and there's no number there. So it's 1, because there's just a single x. It's not being multiplied by any other x's. All right, let's look at the bottom two. Here, in this one, we have a coefficient of 5. So that means it's x squared plus x squared plus x squared 5 different times. And it has an exponent of a 2, which means it's the same as x times x 2 times. Don't forget, your coefficient is still there. You still have that 5 out in front. Last example. Notice this coefficient is negative. Do not forget to include the negative. And if I were to multiply negative 3 times 5, that would be subtracting 5 3 separate times to get negative 15. So if you're multiplying negative 3 times y, you have to subtract that y 3 times. So it's minus y to the fourth, minus y to the fourth, minus y to the fourth power. 1, 2, 3 of them. Now, because the exponent of this example is 4, then we know that it's y times y times y times y 4 times. Don't forget, we still have that coefficient there. All right, let's talk about order of operations in the next video.